So today we're gonna learn to, so we're gonna learn to apply, or we're gonna learn about the use of log models, how to go about interpreting the results that we get from, models with logs. So the example that I have here it's a model related to demand. So we have data from 660 customers, and we're interested in analyzing the effect of prices and income on the demand of two types of apples. So we have the quantity of regular apples, we have price of regular apples, we have the price of organic apples, and also we have family income. So the model that we're considering is a model where we have the log of the quantity demanded of regular apples as a function of the log of the price of regular apples, the price of organic apples, and also family income. So remember, this is related to a demand model where we have like the quantity demanded of a good is a function of its own price, the price of substitutes, and also income. Just to give you a sense of the type of data that we have, so this is the average. This is the standard data on the standard deviation, minimum, and maximum values for each of these variables. So the average quantity demanded of regular apples is 1.38. So we're not going to be using the demand for eco-label apples. So we have the price of regular apples, the average 0.88. The price for eco-label apples, as you would expect, a bit higher, 1.8. And on average, family income is 53,000. And then, we also have the log. So these are the average values for the log of each of those variables. So, again, when you think in terms of logs, it's kind of, hard to understand what's going on there. So it's easier to think in terms of the original values of the variables. So the minimum price for regular apples, 10 cents. Well, the minimum quantity demanded is 0.10 pounds and the maximum 42. The price for regular apples, minimum 0.59, maximum 1.19. Prices for eco-label apples, minimum 0.59, maximum 159. Family income, the minimum $5,000. So this is in thousands of dollars, by the way, and the maximum $250,000, per year. So you have to be a little bit careful that So what are the units, and that's important not only for interpretations, but also for calculations. So the prices. These are dollars per pound. Dollars per pound. Let me see. I don't like this. Well, I'll try to fix it later. Okay, so that's what we have. So the data, we run the regression, so we get the regular results. So remember, this is the standard error of the regression, which we will be using later on. The R-square 0.46, kind of low R-square. But if we look at the statistical and the p-value, we conclude that the model is useful for prediction. And we have our estimates of the coefficient. So this is beta 0 hat, beta 1 hat, beta 2 hat, beta 3 hat. Okay, the standard errors, if we look at the p-values, we see that the three first coefficients are significant at the 5 or even 10% level, but we don't find evidence of an effect of family income for this specific application at the 10% level or lower. Okay, so let's practice. So is the model useful to express the quantity demanded? So remember, that's supposed to be the first thing that you look at, that F statistic. And the answer is yes, because the F statistic, the F stats p-value is lower than 0.05. Okay, and also we can do to practice the R-square, 0.046, and the model we also know that 4.6% of the variability in the quantity demanded. Quantity demanded of regular apples is explained by the model. Okay, so notice that here the dependent variable is really the log, but usually you don't say that 4.6% of the variability in the log of the quantity demanded is explained by the model. We just say, we talk about the name of the original variable. And I wanted to make that point here. Okay, so let's continue. So what variables are statistically significant? At the 5% level, so again, if we go back, we know that it's the log of the regular price and the log of the eco price. And also at the 1% level, family income is not significant at the 5 or even 10% level. So at the 5% level, we know the natural log of the price of regular apples and also the natural log of the price of eco-level apples, and the same here. I'm going to be using the names I used when I wrote the question. Okay, so they are both significant. Family income is not. So saying interpret the statistical significant coefficients and discuss their economic significance. So we have beta 1 is equal to minus 0.73, beta 2 0.74. So let's go back. I'm going to show you where is that I got those numbers. So you see I have 0.73 and minus 0.74. So the one is related to the price of regular apples, and the second one is related to the price of eco-label apples. Okay, so this one, again, we said that these are elasticities, so we interpreted, we said that a 1% increase in the on price so remember, this is the price of regular apples. Price of regular apples. Oops, let me change this one. So 1% increase in the on price, which is the price of regular apples, decreases the quantity demanded, decreases its quantity demanded by 0.73%. Okay, so this is what's called the on-price elasticity. So this is the on-price elasticity. Okay, so the coefficient for beta 2, again, is also elasticity. So we can say that a 1% increase in the price of eco-label apples increases the quantity demanded of regular apples by 0.74%. Okay, as you can see, that coefficient that we estimate is actually the elasticity, and it has a very straightforward interpretation. So this is what's called, remember from your microeconomics class, so this is the cross price elasticity, because you are looking at how the effect of the price of other goods affects the quantity demanded of a certain good. So this is a cross price elasticity, something that we say here. So discuss their economic significance. So remember that basically in both cases we're saying that they are inelastic. If you remember, goods are elastic if the elasticity is equal to 1. That's unitary elasticity. So they are elastic if it's higher than 1, and they are inelastic if it's less than 1. So 0.73, that means that, eco-label apples are inelastic with respect to its own price, and also with respect to the price of another good. Now here, something that if I were in class, I would ask you, okay, based on the result of this cross price elasticity, I would ask you if eco-label apples are complements or substitutes for regular apples. Okay, so this is the question based on that sign. So are eco-label apples complements or substitutes? Oh, I'm going to have to go up a little bit. Complement or substitutes to regular apples. Yeah? So what do you think? Well, in this case, they happen to be substitutes. Okay? Remember that and think about it. You see, if the price of eco-label apples increases, people substitute and start to buy actually more regular apples. Okay? So have that in mind. So the next question is, sketch the relationship between each variable that is statistically significant based on those signs. So again, sketch, we only need to know the shape. So this is regular quantity demanded, and this is the price. Oops. This is regular price. And this is the eco price. Okay, so let's go and see the shapes that we had discussed in the previous class. So remember, for the on-price elasticity, we have that beta 1 is less than 0 because it's minus 0.73. So the shape should be this one. Okay, and for regular apples, so remember, beta 1 is less than 0. It was minus 0.73, beta 1 hat. Okay, beta 2 was 0.74, which it should be this relationship between because beta 1 is higher than 0 but lower than 1. I think that there was an error actually in the previous lecture that was supposed to be beta 1 higher than 1. Okay, so I catch that error right now. Yeah, so the relationship should be higher than 0 and lower than 1. Let me see the shape again. Let's look like this. So beta 2 hat higher than 0 and less than 1, and it was equal to 0.74. So, the first graph, remember, that's kind of like the law of the demand. As the price increases, the quantity demanded decreases. So that's consistent with the law of the demand. So the last thing that I want us to do today is to calculate the predictions. Okay, I didn't have it here. So actually this is the last part of the example. So predict the quantity demanded of apples, well, of regular apples, when the price of regular apples is $1 per pound. The price or eco-label apples, let's assume that's $1.20 per pound, and let's assume for family income $50,000. And since we have in thousands of dollars, we just need to write 50, and you have to be a little bit careful here when you are doing examples, because if the units are 50,000, you only need to write 50. Okay, so remember we said that the formula to calculate the value of the dependent variable when we use a log model, we have to use this equation. Okay, so we need two elements here, the predicted value of y and also the square of the standard deviation of the regression divided by 2. That's already calculated, so we'll take it later on. So for now, let's focus on estimating the predicted value of our quantity demanded, which we call it, so this is regular price. So that should be equal to 0.67 minus 0.723. Well, let me look at exact values to see. So 0.668, 0.729, and 0.743. 668. Let me see. Give me a second to have it here in front of me. The result. Okay, so it's going to be 0.668 minus 0.729. So, and that's the log of regular price plus 0.743, that's the log of eco price, and minus 0.054 times the log family income. Okay, so let me write this nicer. Okay, so and we have to plug in here these values that we had, so we have regular price. Let me see. Okay, so we had the regular price here, and my pen stopped working. So the regular price here, the eco-level price here, and family income should go here. And we just have to plug in those values there. So the log hat of regular apples is equal to 0.668 minus 0.729. Should be the log of 1 plus 0.743. The log of 1.20 minus 0.054 should be the log of 50. Okay, so if we do all these calculations, we should end up with 0.5091 to save some time. You can check using your calculators. So now we need E to the sigma square hat divided by 2. So where did I get this value? So remember, we have to go to the results of the regression, and we had that sigma 0.614. So that's what we had to square and then divide by 2. So it should be E to 0.614 squared, that divided by 2 is equal to 1.28. Okay, 61.4. After we do the calculations, so the predicted value for regular apples, again, I'm going to write it here. The log should be 1.28 times E to the 0.5091, which we already calculated. Oops. 0.5091, and that's equal to 2.18 pounds of regular apples, which is the quantity predicted of regular apples when the price for regular apples is $1. The price for eco-label apples is 1.20, and family income is 50. Okay, and with this example, I'll show you how we can go and use the results of regression model when we use logs. So this is the population model that we estimated. So we looked at the model was useful for prediction. We look at which coefficients were statistically significant. We interpret the coefficients as elasticity, sketch the shape of the relationships. It was supposed to be the demand. Remember, that's the law of the demand. And we also predicted the quantity demanded, okay, using the procedure and the formulas described in the previous class.